Finding voltage on a light pole that has been disconnected from its incoming power feed can be concerning. The presence of 130 volts even after disconnection and the fluctuation of voltage from 130 volts at the top to approximately 26 volts at the bottom suggests a few potential causes. It is important to understand these causes and take appropriate steps to ensure safety. Firstly, induced voltage from high voltage lines could be the source. If there are high voltage wires in close proximity to the light pole, they can induce a voltage within the pole through electromagnetic induction. The magnitude of this induced voltage can vary depending on the load carried by the high voltage lines, causing the observed fluctuations. Secondly, capacitive coupling is another possibility. The light pole and the high voltage wires can act as a capacitor, storing and releasing electrical energy. This capacitive coupling can result in a voltage being present on the pole, even when it is disconnected from the main electrical grid. Thirdly, while less likely to be the primary cause of 130 volts, static electricity can build up on the light pole due to environmental factors like wind or friction. However, given the presence of high voltage lines, induced voltage or capacitive coupling is more probable. Due to the risk of electrical shock, the voltage on the light pole poses a safety hazard. Addressing this issue promptly is crucial to prevent potential injuries. The following recommendations should be followed. First, contact a qualified electrician. A licensed electrician has the expertise to inspect the light pole, identify the precise source of the voltage, and recommend appropriate safety measures and repairs. It is not advisable to attempt troubleshooting or repairs without professional assistance. Second, grounding the light pole can help dissipate induced voltage. An electrician can install a proper grounding system to provide a safe path for the voltage to discharge, reducing the risk of electrical shock. Third, consider installing surge protection. Surge protectors can help prevent damage to electrical equipment from voltage spikes caused by induced voltages or static electricity. These devices can safeguard the light pole's electrical components. Fourth, regularly monitor the voltage on the light pole using a voltmeter. If the voltage fluctuates significantly or remains consistently high, contact an electrician immediately. This ongoing monitoring can help detect potential problems early. Finally, train staff to recognize the safety hazards associated with electrical voltage and instruct them to report any unusual occurrences or concerns. Awareness and proper training can help prevent accidents. It is important to note that working with electricity can be dangerous. Always prioritize safety and consult with qualified professionals when dealing with electrical issues. Do not attempt any repairs or modifications unless you are a licensed electrician with the necessary expertise and equipment. The electrician will likely conduct several tests to determine the exact cause of the voltage. These tests may include measuring the voltage at various points on the pole, checking the grounding system, and using specialized equipment to detect induced voltage or capacitive coupling. Once the source of the voltage is identified, the electrician can recommend the most appropriate course of action. This might involve improving the grounding system, installing shielding to reduce induced voltage, or making repairs to the electrical components of the light pole. In addition to addressing the immediate safety concerns, it is also important to consider the long-term maintenance of the light pole. Regular inspections and maintenance can help prevent future problems and ensure the continued safe operation of the lighting system. These inspections should include checking the condition of the wiring, connections, and grounding system, as well as testing the surge protectors. By taking these steps, you can help protect people from electrical hazards and ensure that the lighting system operates safely and reliably. Remember that electrical safety is paramount, and it is always best to err on the side of caution. If you have any doubts or concerns, consult with a qualified electrician. Additionally, local electrical codes and regulations should be followed when addressing electrical issues. These codes are designed to ensure safety and prevent electrical hazards. An electrician will be familiar with these codes and can ensure that all work is performed in compliance with them. Understanding the principles behind induced voltage and capacitive coupling can be helpful in preventing future problems. Induced voltage occurs when a conductor, such as a light pole, is exposed to a changing magnetic field. This changing magnetic field can be created by nearby high voltage lines. The strength of the induced voltage depends on the strength of the magnetic field, the length of the conductor, and the distance between the conductor and the source of the magnetic field. Capacitive coupling occurs when two conductors are separated by an insulator, forming a capacitor. In the case of a light pole and high voltage lines, the air acts as the insulator. The amount of capacitive coupling depends on the size of the conductors, the distance between them, and the properties of the insulator. To minimize induced voltage and capacitive coupling, it is important to maintain a safe distance between the light pole and any high voltage lines. Shielding can also be used to reduce the amount of electromagnetic radiation that reaches the light pole. This shielding can be in the form of grounded metal enclosures or other conductive materials. Proper grounding is also essential for minimizing the effects of induced voltage and capacitive coupling. A good grounding system provides a low resistance path for current to flow to ground, reducing the voltage in the light pole. The grounding system should be regularly inspected and tested to ensure that it is functioning properly. In addition to the above recommendations, it is also important to consider the design of the light pole itself. The height and shape of the pole can affect the amount of induced voltage and capacitive coupling. Taller poles are more likely to be exposed to stronger magnetic fields, while poles with larger surface areas are more likely to experience capacitive coupling. The materials used to construct the pole can also affect its electrical properties. Conductive materials, such as metal, are more susceptible to induced voltage than non-conductive materials, such as wood or plastic. By carefully considering these factors, it is possible to design light poles that are less susceptible to induced voltage and capacitive coupling. The presence of 130 volts on a disconnected light pole is a serious safety concern that should be addressed immediately. By following the recommendations outlined above, you can help protect people from electrical hazards and ensure that the lighting system operates safely and reliably. Always remember to prioritize safety and consult with qualified professionals when dealing with electrical issues. The situation involving the light pole with unexpected voltage readings requires a systematic approach to identify and resolve the problem. Firstly, we verify the disconnection. Ensure the 208-volt feed is completely disconnected and isolated from the light pole. Use a calibrated voltmeter to confirm the absence of voltage at the point of disconnection. Secondly, measure voltage to ground. Use a calibrated voltmeter to measure the voltage between the top of the pole and a known good ground reference, such as a properly grounded metallic water pipe or grounding electrode. Measure the voltage between the bottom of the pole and the same ground reference. Record these measurements. Thirdly, check for continuity to ground. Use an ohmmeter to measure the resistance between the light pole and the known good ground reference. A low resistance close to 0 ohms indicates a good ground connection, while a high resistance indicates a poor or non-existent ground connection. Fourth, inspect the grounding system. Visually inspect the light pole's grounding system for any signs of damage, corrosion, or loose connection. Ensure that the grounding conductor is properly connected to the pole and to the grounding electrode. Fifth, assess proximity to high voltage lines. Carefully observe the proximity of the light pole to the overhead high voltage lines. Note the distance between the pole and the lines, as well as the configuration of the lines, e.g. single pole, double pole transmission tower. Sixth, consider weather conditions. Note the weather conditions at the time of the voltage measurements. High humidity, rain, or fog can increase the conductivity of the air and exacerbate induced voltage or capacitive coupling. Seventh, investigate nearby electrical equipment. Check for any other electrical equipment in the vicinity of the light pole, such as transformers, switchgear, or other lighting fixtures. These devices could be contributing to induced voltage or capacitive coupling. Eighth, consult with the utility company. Contact the local utility company and inform them of the situation. They may be able to provide additional information about the high voltage lines in the area and any potential sources of interference. Ninth, perform insulation resistance testing. Use a megometer to measure the insulation resistance of the wiring and electrical components within the light pole. Low insulation resistance can indicate damaged insulation, which can contribute to leakage current and voltage on the pole. 10th, consider electromagnetic field EMF measurements. Use an EMF meter to measure the strength of the electromagnetic fields around the light pole. High EMF levels can indicate the presence of induced voltage or capacitive coupling. Following these steps will help to identify the source of the voltage on the light pole and determine the appropriate course of action. The presence of voltage on a disconnected light pole is unusual and potentially dangerous. It is important to investigate the cause of the voltage and take steps to eliminate it. Possible causes of voltage on a light pole include induced voltage from nearby power lines, capacitive coupling, static electricity, and ground faults. Induced voltage occurs when a conductor, such as a light pole, is placed in a changing magnetic field. The changing magnetic field induces a voltage in the conductor. The amount of induced voltage depends on the strength of the magnetic field, the length of the conductor, and the distance between the conductor and the source of the magnetic field. Capacitive coupling occurs when two conductors are separated by an insulator. The two conductors form a capacitor. When a voltage is applied to one conductor, a charge is induced on the other conductor. This charge can cause a voltage to appear on the second conductor. Static electricity is a buildup of electrical charge on a surface. Static electricity can be caused by friction, induction, or conduction. Ground faults occur when a live wire comes into contact with a grounded surface. This can cause a large current to flow through the ground wire, which can trip a circuit breaker or fuse. If you suspect that there is voltage on a light pole, you should take the following steps. Firstly, do not touch the light pole. Voltage on a light pole can be dangerous and can cause electrical shock. Secondly, contact a qualified electrician. An electrician can safely measure the voltage on the light pole and determine the cause of the voltage. Thirdly, follow the electrician's instructions. The electrician will recommend the appropriate steps to take to eliminate the voltage on the light pole. In addition to the above steps, you should also take the following precautions. Firstly, keep children and pets away from the light pole. Children and pets are more likely to touch the light pole and get shocked. Secondly, do not use the light pole as a support for ladders or other equipment. This can damage the light pole and increase the risk of electrical shock. Thirdly, report any damage to the light pole to the appropriate authorities. Damage to the light pole can increase the risk of electrical shock. By following these precautions, you can help to prevent electrical shock and ensure the safety of yourself and others. The investigation of the light pole voltage issue should include the following considerations. Firstly, review the original installation records for the light pole and the surrounding electrical infrastructure. This may provide clues about the grounding system, wiring configurations, and any potential modifications that have been made over time. Secondly, consider the possibility of underground utilities or metallic structures near the light pole. These could be contributing to induced voltage or capacitive coupling. Use a cable locator to identify any buried utilities in the area. Thirdly, examine the light pole's luminaires and ballasts. Faulty or aging components could be generating leakage current that is contributing to the voltage on the pole. Fourthly, evaluate the effectiveness of the light pole's lightning protection system, if one is installed. A malfunctioning lightning protection system could be diverting surge current to the pole, resulting in elevated voltage levels. Fifthly, assess the soil conditions around the light pole. Soil resistivity can affect the effectiveness of the grounding system. High soil resistivity can limit the ability of the grounding system to dissipate voltage. Sixthly, consider the possibility of vandalism or tampering with the light pole's electrical system. Unauthorized modifications or damage could be contributing to the voltage issue. Seventh, analyze the voltage fluctuations over time. Record voltage readings at different times of day and under different weather conditions. This may reveal patterns that can help identify the source of the voltage. Eighth, consult with other experts in the field. Seek advice from experienced electrical engineers, grounding specialists, or utility company personnel. They may have encountered similar situations and can offer valuable insights. By thoroughly investigating all potential factors, it is possible to identify the root cause of the voltage on the light pole and implement effective solutions to ensure safety and prevent future occurrences. The potential hazard presented by the voltage on the light pole necessitates a comprehensive safety protocol to protect workers and the public. Firstly, establish a safety zone around the light pole. Use barricades, caution tape, or other barriers to prevent unauthorized access to the area. Post warning signs indicating the presence of electrical hazards. Secondly, ensure that all personnel working on or near the light pole are qualified and trained in electrical safety procedures. They should be equipped with appropriate personal protective equipment (PPE), including insulated gloves, safety glasses, and arc-rated clothing. Thirdly, de-energize the light pole's electrical circuits whenever possible. Before performing any work on the pole, disconnect the power supply at the source and verify that the circuits are de-energized using a calibrated voltage tester. Fourthly, use insulated tools and equipment. When working on energized circuits, use only insulated tools and equipment that are rated for the voltage levels present. Fifthly, maintain safe distances from energized conductors. Keep a safe distance from any exposed energized conductors or equipment. The minimum safe distance depends on the voltage level. Sixthly, avoid working in wet or damp conditions. Water can conduct electricity and increase the risk of electrical shock. If it is necessary to work in wet conditions, take extra precautions to protect yourself from electrical hazards. Seventh, be aware of the potential for induced voltage. Even when the light pole circuits are de-energized, induced voltage from nearby power lines can still be present. Use a voltage tester to check for induced voltage before touching the pole or any of its components. 8. Have a qualified first aid provider on site. Ensure that a qualified first aid provider is present during all work activities. The first aid provider should be trained in CPR and the treatment of electrical shock. 9th, develop an emergency response plan. Create an emergency response plan that outlines the procedures to follow in the event of an electrical accident. The plan should include contact information for emergency services and instructions for providing first aid. 10th, document all safety procedures and training. Keep records of all safety procedures, training sessions, and equipment inspections. This documentation can be used to demonstrate compliance with safety regulations and to identify areas for improvement. By implementing these safety protocols, you can minimize the risk of electrical accidents and protect workers and the public from harm. Regular review and updating of the safety protocols is essential to ensure their effectiveness. The investigation into the voltage on the light pole should also consider the potential for stray voltage from other sources. Stray voltage is a low-level voltage that can be present on grounded metal objects such as light poles, fences, and water pipes. It is typically caused by leakage current from nearby electrical systems. Stray voltage can be difficult to detect and can pose a shock hazard to people and animals that come into contact with the affected objects. Possible sources of stray voltage include faulty wiring, damaged insulation, and improperly grounded equipment. To investigate the potential for stray voltage, the following steps should be taken. Firstly, perform a stray voltage survey. Use a specialized stray voltage meter to measure the voltage on various grounded metal objects in the vicinity of the light pole. This survey should include light poles, fences, water pipes, and other metallic structures. Secondly, identify potential sources of leakage current. Inspect nearby electrical systems for any signs of faulty wiring, damaged insulation, or improperly grounded equipment. Pay close attention to transformers, switchgear, and other high-voltage equipment. Thirdly, test the grounding system. Verify that the grounding system is properly installed and functioning correctly. The grounding system should provide a low-resistance path for current to flow to ground, which can help to minimize stray voltage. Fourthly, consult with a qualified electrician or stray voltage expert. An experienced professional can help to identify the source of the stray voltage and recommend appropriate solutions. Solutions for mitigating stray voltage include repairing faulty wiring, replacing damaged insulation, improving the grounding system, and installing isolation devices. Isolation devices can be used to electrically isolate the affected metal objects from the source of the stray voltage. The investigation of stray voltage should be conducted in a safe and systematic manner. Always use appropriate personal protective equipment and follow safe electrical work practices. If you suspect that there is stray voltage in your area, contact a qualified electrician or your local utility company. They can help to investigate the problem and take steps to eliminate the hazard. Addressing stray voltage issues is essential to protect people and animals from electrical shock and to ensure the safe operation of electrical systems.